Old Zoom is gone. I mean, it's probably still there if you want to see them because I recorded, I don't have access to them. But you don't have access to them unless I open them up. So let me know if you want to see them, but I'm now doing something else called live streaming on YouTube. So if you're looking for the link to it and it's not on my announcements, I'll send it out. Okay. All right, so how do you do with quiz? So the test, so let's just talk about the test. You had to go into Honor Lock. And this test was basically, part of this test was to see if you could get Honor Lock to work with Alex.
Yeah, Professor,
Yeah.
that's my main issue. I don't know if you could see my screen right now. I'm about to share my screen. The honor lock system has been stuck on this for like the last 2-3 hours.
Did you talk to Honor Lock help?
Hmm?
You went to Honor Lock help and they,
Yep, I tried everything with the need help, everything.
security
I've
check.
restarted a authentication process here. Click it. I don't know if it's gonna work now, but try to do that. Close tab. It's just been stuck on this.
And they can't help you?
Nope.
Can use a different computer?
My MacBook's my only access.
But you could use a library computer if you wanted to. I suspected something with your computer. Yeah. Yeah, you can library and take tests there.
Okay.
Yeah. So that's one of the things I need to have you, because the midterm is also on Honor Lock and on Alex. It's not the same because this test was a knowledge check. The midterm is an actual test, more like the quizzes. Okay. But this was more of, I didn't want you to stress about studying for it or anything at this point. The midterm is where we're going to stress, which is coming up in a couple weeks, but okay. Let me see. Am I live streaming? It says I'm live streaming. Okay, why didn't I see that? Come on. Okay, so let's
Yeah, it says you're connected to YouTube.
okay. So let's talk about so then you had test one, and it was just a knowledge check. It was based on 25%. So quite a few you got hundreds on it. Some of you did closer to 25%. Some of you did much better. That's great. More you know, the better. And quiz 5. Take a look at quiz 5 and see what you did wrong on quiz 5. Need any help with quiz 5? Okay, let's take a look at this one. Okay. So I'm going to follow up that follows. That's a good one. Okay. So it says graph this function. Graph the function and its asymptotes. So I'm just going to go right into Des. I'm going to graph it. G of x equals 4e raised to the x minus 1. Okay, plus 4. Now you can see from this, it's not the same. See how that minus 1 is not in the exponent? By the way, this topic is called exponential functions, so it's very important that that actually not be there. So I'm going to cut it out. One way you can get it into the exponent, I think you can put it here, like that. Like if you have something in there, or if you, or you could just put parentheses around it and make sure it stays up in the exponent. Do you see the difference between that and what there was before? All right, now, the next thing we have to do is look at the graph and we have to find the asymptotes. Okay, we have to know something about exponential functions. Do you remember what I said last time about exponential functions? Do they have asymptotes? Yes. Do they have a vertical or horizontal asymptote? What's special about exponential functions. On one side, they grow up like a polynomial. On the other side, they're flat. I used to, on one side it's flat, and the other side it goes up like a fencing person. Okay, that flat side, that's a horizontal asymptote. Do you see what looks like a horizontal asymptote here where the line flattens out? Do you see it? It goes up on one side and it's flat on the other. Where might that line be? What number do you think that is? Looking at these points here. What are the y values every time? Anyone? What's the line here? Where is it? What are the y values? You see 4. So horizontal asymptote, y equals 4. And here, I can go in here if I want to be fancy, and I can make it a dashed line. That's a horizontal asymptote. And when we do the function, we're going to have to put, we're going to have to, on Alex, it's not on this. I'm going to have to put the line, I'm going to have to draw a horizontal asymptote. Here's the horizontal asymptote. I'm going to have to put it at 4. Yeah. And then I'm done with that. Okay, I'm not done with the graph though. You see that plus 4? So e to the x has a horizontal asymptote at 0. The plus 4 raises it up by 4. You add what's outside, that's what it does. The 4 here just stretches it. If I change that to a 2, you see how the horizontal asymptote stayed the same? Or if I change it to a half, see, the horizontal asymptote doesn't change. Okay, that number stretches this graph. And so it's mostly flat on one side, and the stretching you mostly see going up the other side. All right, what does the -1 do? That moves it left or right. Okay, so in this case, again, if I make it -3 or whatever, you're not going to see much there. It moved a little bit to the right. If I put a plus in there, it'll move it to the left. Okay, but it isn't changing it. Ooh, I put it in the wrong spot. Okay, so let's get back there. See, I put the +2 down there with the 4, and then it moved up. Okay, so now the next thing I need are to plot some points. One of my students showed me this. You just hit the little wrench thing, the gear, whatever that is. You hit that, and you hit the little table thing. It'll give you a table of values. Okay, and there they are plotted for you. But I don't, what's going to happen is they want 2 values that aren't like this. They don't want all this messed up stuff here. So I see one that I can use is 2. But I could I could try more. But 2 is the only one that's going to work here. I mean, I can hit return and it'll give me 3, 4, 5. You see, none of them work. Only 2 works. Why did 2 work and none of the other ones work? Look at the function. When I plug, oh, I changed this, didn't I? What was the number before? Shoot. Hold on. What's that number? Anybody? 4. Okay. Okay, so 2, 8. So I can go over here and I can plot the point 2, 8. And why did 2 work and none of the other work? None of the other ones work. So I can plot a point 2 and 8. Plot the point. But they want more. They plot 2 points. So I need to find another point. But look at this little template-y thing. Do you see there's a little letter E there? Okay, so that's useful to know. So why did 2 work? Well, if I plug 2 into that x value, what is 2 minus 2? 0. What is anything to the 0 power? 1. Okay, so e raised to the 0 power is going to be 1. So 4 plus 4 is 8. Fine. That's how I found it. Are there any other numbers I can raise e to that's going to give me... Oh. All these other numbers is because e can't be raised to any power without giving you some irrational number, except 0. The 0 is the only one. So to get another point, I won't be able to use Desmos exactly. I'm going to have to do this. I'm going to do this. If I want g of, give me a number, 0. Let's try 0. If I do 0, that's gonna be equal to what? 4 e to the what power? What is 0 minus 2? Okay, you guys gotta talk to me. I'm gonna get bored and leave. Okay. There's plus, so do you see I just plugged 0 into that function? I got that. So now I can plot this as a point. I over here and I plot the point 0. And I just type all of that in. 4 e raised to the negative 2 plus 4. I plot that. Now, when I look at this thing, it should have plotted 2 points for me. There's 2 points. Now all I have to do is click that and it will finish it. Okay. So for this particular, oh, it's wrong. Why is it wrong? Let me see what's wrong. Is that -1? And I typed in -2. Oops. When I put it in decimals, I typed it in wrong and nobody said anything. At -2. So it's -1. Anyway, you see the number that works here now is the number 1 works. And to get the number 0, I can, so this point right here, that point right there must be 1, 8, and this one here is 2. So when you plug 2 in, it's the point where I plug in 2 minus 1. That's just e to the first power. And so they're using the point 2. Okay. Any questions on that? Right, that's all I have to go over. The rest of them looked okay. Okay. Any questions? Where'd it go? Any other questions on Alex? So that was the one that was 38%. And the reason that was hard is because you couldn't use Desmos exactly. You still had to plug it in to get the letter E, and it won't do it any other way. All right. Any other questions in here? Maybe this 51. Yeah, this is a good one to go over, so we'll go over it. Okay. I'm gonna make it big and then I'll make it small. Mr. and Mrs. Murphy hope to send their son to college in 12 years. Okay. How much money should they invest now at 8.5% per year, compounded continuously, in order to be able to contribute $9,000 to his education? Okay. So I don't know if that will do it. Let's see. Copy. My Desmos, here it is. Go to this. Okay, so this is the question they gave us. How much money should they invest now at an 8.5% interest? 8.5%. In order to be able to contribute to his education in 12, in order to be able to contribute $9,000. Okay. All right. They say compounded continuously. Does anyone remember the compounded continuously formula? What is it?
I don't remember exactly, but I know it's A equals parentheses P plus R over T.
Okay, so there's a bunch of them. This interest equals PRT. That's just tells you what the interest is. P is the principal. That's the amount of money involved. R is the rate, and T is the time. That's one of the formulas. Another formula is P equals Q. I use capitals. P equals Q parentheses 1 plus R for N raised to the NT. Okay, does anyone know what that formula was? That was one of the formulas. And I asked for all capital letters and I got no capital letters. Okay, fine. So Q in this case is the initial, so let me do one. So Q is the starting amount. Starting. R is the rate. T is the time. And N is the number of compounds per time period. So it's the number of compounds. So if we were talking about monthly, it would be 12. Monthly is 12 in a year. So if you're getting it. Okay, so it's the number of compounds. All right. Is this compound interest formula the formula that we want when they say compounded continuously? Yes or no? The answer is yes or no?
Yeah.
No. Thank you for answering though. This is compounded, this is compound, but we want compounded continuously. So we don't have the number of compounds. We have this formula for that. P equals QE raised to the RT. Everything means the same, except there's no N. Okay, so we have that S. So we have P, we have the same starting amount. We have the same rate. We have the same number of compounds. We have the same time. We don't have numbers of compounds. So let's just figure out what we do have. So that's the formula that we want. And we have all these things will be the same. Rate, time, rate, starting amount. Okay. What's missing is P, which is the ending amount. Principal. Okay. So what's the starting amount? We don't know. Because in the problem, they're asking us, how much money should they put in for 12 years? Oh, 12 years is what? Which of those numbers is, which of those variables is 12? Starting, rate, time. When is it? Somebody from home. Chris. Oh, you're on an iPhone, never mind. Jake. 12 is which one of 12 years is which one of these? Starting, rate, time, ending.
It's time.
Sure. 12 years. So that's 12. Okay. What's the rate?
8.5.
Thank you, Taylor. 8.5. Okay, so when I write 8.5% means divided by 100. Okay, which is 0.085. Everyone got that? You don't use 8.5, that's 800%. Okay, starting amount. Do we know the starting amount? In order to be able to contribute 9,000. Is that his starting amount or the ending amount? They want to give it to him in the end. So which is it? P or Q? Ending. You want to end with 9,000. So we're missing the starting amount. So in this formula here, P equals QE to the RT. Let me just go here. So I have 9,000 here. I have E raised to the 0.085 times 12. So what I'm missing is that Q. So I'm going to put in X there. When I put in X there, okay, why is it saying you need something on both sides of the equal sign? I have something on both sides of the equal sign. Oh, there's a period there. Okay, so now how does Desmos work? If I type in X equals 2, it gives me a vertical line at 2. Do you see that? It's also telling me the answer is 2. If I write Y equals 2, it gives me a horizontal line. And that could tell me the answer. That Desmos is trying to graph whatever equation you get. But if I write it in a weird way, like y plus 7 equals 2 plus 5. No, 2 plus 3, let's say. There's this solution right there, it's -2. It's trying to graph this. So when I put an x in for the starting amount, there's going to be what type of line? A vertical line or a horizontal line? At x equals y. It's going to be a vertical line, but I don't see a vertical line. Where might it be? How about I zoom out? Because we're talking thousands of dollars. Do you see a vertical line? Where is it? Right here. You see every x value is 24,957, 20. It's that. Which just hold for a second. Yeah, so that's the answer right there. Okay. That can't be right. What's wrong with that number? They're putting $24,000 into the bank. And then after 12 years, it's going to only be $9,000. What's happening to their money? It's decaying. But that's not right. So what's wrong with my equation? 9,000 is correct. X, that's what we're looking for, right? What's that? That's a negative number. That means decay. Oh, so let me just take that negative out. Oh, look there, my number is different now. What is it? 3,000. Could that be the answer? Put 3,000. Could they put 3,000 in the bank and 10 years from now it'd be $12,000? Okay. The interesting thing is yes. Yes, very much so. So the answer is that 3, 2, 4, 5, 35. I want you to know something about 8% interest. You guys, when I was in college, 5% was the thing. So all the problems. So I knew this about 5%. Money doubles at 5. If you put it in the bank, 5% interest. In 13 years, it will double. Okay. So if I went to college 26 years ago, how about 39 years ago? I went to college 39 years ago. If I put $5 in the bank at 5% interest and it stayed at 5% interest, it would have doubled from $5 to $10 in the first 13 years. And then it would have doubled again in the next 13 years. So it would have been, now it would have been $20. And then it would have doubled again in the last 13 years. So it would be $40. So my $5 would be $40. And you might say, that's not so bad. That's not interesting. Except let me talk about your tuition. When I went to college, it was $5,000 for tuition. Tuition has been growing at about 5%. So it doubled 13 years later. So it was $10,000. And it doubled 30 years later. So that's $20,000, right? $20,000. Wait, I went to, it's 39 years ago. So that's 3 times it doubled. So it went from 5 to 10, 10 to 20, 20 to 40. So your tuition, should I say, and by the way, that's about correct. Now, how much it costs to go to Rutgers now? $40,000. Just saw it on that. So that's what 5% does. It doesn't seem like much, but when I went to college, it was $5,000. Now it's $40,000. Do you know what's going to be in 13 years when your kids go to college?
So,
I don't know. You want to figure it out? Let's figure it out. We're going to use that. Then we're going to use that same thing. We're going to use this PQRT thing. By the way, can I delete everything else? I don't need this. Don't need it. Don't need it. Don't need it. So I'm just using PQRT. And by the way, I can just change these things. So I can say, I don't know. I want to figure out what it's going to cost to go to college. Oh, do that. And here's how I can do it. I can figure out what the rate is. Well, if the rate is 5%, and it doubles At 5%, it doubles every 13 years, but how many years? What's it cost now to go to Rutgers? So I told you it was $40,000 to go to Rutgers now. It's 5% interest. How many years is it going to be before you have kids? You're gonna have kids right away, like tomorrow? Anyone pregnant? Pregnant?
20
Anyone?
years.
20 years? Really?
Maybe like 15. 15, yeah, 15.
Okay, so let's do both of them. 15 years. The answer is going to be your kids are going to be. I don't have to, it's right here because it says P equals Q. You have to take $84,000 to send your kids to school. In 15 years, because that's close to 13 years. Okay, what did you say? 20 years? You know what's going to be in 20 years? $108,000. That's only 5 more years, and you're going to pay. You better have those kids now. Because if you have them now. Oh, wait, I forgot to add the 18, didn't I? What were you going to say, AJ?
Oh, no.
Yeah, I was gonna say like it doesn't have to.
If you have, right now, it'll take 18 years before they go to college. Right now, 18, it's $98,000. If you wait 5 years or 15 years, that's, you're gonna wait 15 years? No, you're gonna wait.
Maybe school will be free by then.
Let's say 10 years. Yeah, sure, that'll happen. 10 years from now, 10 years and 8 is 28 years, $162,000. So if you wait 10 years to have kids, you wait till you're 28. This is why your parents want you to have kids now. It's not that they want grandchildren, it's that they don't want to pay $162,000 a year for tuition. Anyway, what were you going to say, AJ?
I was just gonna ask, like, what, like, makes, like, the cost of the college, like, fluctuate? It's like, if you went to school when it was, like, 5,000, like, what made it become, like, 40,000 now?
By the way, it wasn't 5. I'm older than that. It was $10,000 for me to go to school. For 4 years as an out-of-state student to go to Rutgers. So it was a lot cheaper. It was like $500. The tuition was $500. Let's figure out how much is the tuition here? Oh wait, I said it was 40,000. So it's 40,000. I'm about to figure out what my age is. 40,000. I know because I looked it up. Rutgers tuition is $40,000. I paid 500. The rate was about 5%. So when did I go to school? So to solve this equation, I just have to, I'm hoping that it will graph it. So I don't know what T is, it's some unknown. So I'm going to replace the T with an X in this equation and see if it will tell me when I went to school. Okay, so it's a vertical line, P equals QE to the bar, PQ bar X. Okay, so where is this? Where is this? No, it just graphed it. No, that's not going to do it. Let me do it this way. I'm just going to put it right into the equation. 40,000 equals 500. The rate is 0.05. Okay, and there's a vertical line here. It's not right. There's no way I went to school. It grew 5%. If it grows 5%, how many years is that? I'm trying to solve for X. And it's telling me how many years that is. Oh, sure. How many years ago was that? That's not right. That's telling you I went to school 87 years ago. 7 years ago. Well, first of all, I don't think Rutgers tuition is 40. I think I was wrong. I think it was 35. Okay. That's still 50. That's still that's 85 years ago. Yeah, so what you're asking, AJ, is what if the price did go, it didn't just grow by 5%. Because if it had grown by 5%, I would be in my 80s. Okay. So it must be more like maybe 6%. If it grew by 6%, I'd still, okay, that would be 71 plus my age at 18, so that would be, I would make me 88 years old. I look really good for 88, I think. Anyway, it didn't grow by just 6%, but it's a lot more expensive than it was. There was subsidies when I went to school. Now you have financial aid. So they make the price, they do the same thing in hospitals. Used to be, when I was born, my mom paid the hospital like $200. She go to the bank and get $200 and she paid the hospital $200. Now the hospital charges $20,000, but it goes to your insurance company or whatever. You don't pay that. Insurance company pays it, but the hospitals jack up the prices so much so you couldn't possibly just go to the bank and get money and pay. Okay, anyway. Exponential, this whole exponential growth thing is your life. Everything is growing exponentially. Nothing is the same. You have balances, you have the money, you've put money in your mattress and you're actually losing money. Because if you're not making money on the money that you're saving, then you're falling behind because it's going to have less, it's going to buy less. Okay. Anyway, that's good stuff, but I'm just going to, I don't know what happened to my screen. All right, let's move on. So that's the end of these things. Okay. They're very useful and they come in different forms, but as far as I'm concerned, I'm saving you all the hassle of trying to figure out how to solve these equations. You just put the numbers in and let Desmos solve the equation. Okay. There's a lot of pain in that. There's sections that it's not just that easy. All right. What else? How did we do with our discussions?
You didn't post it.
I didn't post last week's discussion. So where did you put that?
Exponential regression, right?
Yes, where is it?
I have a screenshot. I'm just waiting for you to post it. Yeah.
Okay, so you want me to do that now so you can post them? Fine, let's do it. But next time, tell me. Because since I have a lot of exams going on this week. I am. So where do you expect to see that? Under lessons?
Yeah, this discussion.
Discussions? Okay. And this is called, what is it called? Exponential regression?
Yep.
Here, might as well just create the next one too. Next one is called logarithmic regression.
Yeah, natural log regression.
All right, so there they are. They're both there. So it's mod 5 and mod 6. All right, so you know what you're doing. You're going into your you're going to open up your worksheet. Okay, I'll open up the sample worksheet and you're going to go down to exponential regression. You're going to turn it on and there's an exponential regression. You're going to find the value. 8.86. Is that evaluating or solving? What am I doing there? That's true.
Thank you, sir.
What am I doing? Is that an evaluate or solve? How about the number 100? Is that an evaluate or a solve? This is a table where I plugged 100 into that equation. You really should know this by now, sort of. What does it mean? Is it evaluate or a solve? 50-50. Somebody say something. I'd rather hear something than nothing.
Oh,
Okay. Which one, the 100 or the 8.83? Is that evaluate or solve?
That the 100 would be the solve.
Thank you for answering. But it's the evaluate.
Oh,
You're plugging it in. When you evaluate it here, you're plugging in the 100 into that equation. Another way of writing that would be. All right, let me just circle on here. Another way of writing that would be E of 100. That's what evaluates do. I plug it in and I get that number. See that? That's an evaluate. A solve is for me to say, okay, I want E of X to be equal to 500. Okay, there's 500 right there. And when I click on it, I get X equals 8.82. Okay, that's a solve. Remember that?
it was just like, it's just a function, correct?
What, excuse me?
Would it just be like, it's just like a function, right?
I'm not sure what you're saying. If I evaluate, I just plug the number into the table or into the function. Okay. So there's the table. These are just the table of values. If I charge $100, I'll sell like nothing. I won't even sell a 1. If I charge $8.83, how many will I sell?
500.
500. Yep. That's what that line means. If I want to know how much it costs to do 1, I have to put in the equation y equals 1. So now if I look for the intersection of 1 and that purple line, looks like it happens somewhere here. So I need to find where the blue line and the purple line intersect. Somewhere around here, maybe. Somewhere in this area. It might be easier just to, what am I looking for? If I want to solve that, why don't I just write it that way? No, I'm trying to find it and I'm not doing a good job. Let me try the wrench. I'm looking for things near the number 1, so I'll try 0 and 2. Okay, that's better. Okay, there, right there. So $71.82. If I charge $71.82, I should sell 1 of them. I did, just 0.999, that's 1. Okay. So the evaluator is going to write that, and solve's going to write that. The speaker is going to say, according to exponential regression, if we charge out. Now, then the next thing you're going to do, once you do that, is you're not going to waste any time. You're going to go right to the natural log regression, and you're going to repeat the exact same thing. Okay, you're going to turn the so let me turn the exponential off. I take a picture of it and I post it, and everyone's happy. Now I'm going to turn the natural log regression on. Okay, get home. I don't see nothing. There it is. Okay. So that's fine. If I want my data and everything, I should go up to the top where it says introductory data and I can put my data in. Oh, that's terrible. It's a terrible regression. Okay, but I don't really care. All I need is I want to sell 500 items. So I click on the intersection of where 500 hits my logarithm. And what price do I charge to sell 500? What price do I charge? Anyone?
10.
About
Yeah,
10.30. Yep. And I'll sell 500 of them. If I put $10.31 in there, you see I get 500. Is that an evaluate or a solve? When I did this process here and I looked for the X value, I was doing what?
Solving.
Or solving for X, I was about to say.
Wait.
I'm doing what for X? I'm solving for the X value. X is what you solve for. this 20 right here, when I plug 20 in, is that an evaluate or a solve? By plugging in 20, I am
Wait, solving.
I'm evaluating. Look, the function, when I write a function like this, n of x, think of it as the value of a car. What do you guys like? Cars? Computers? What would you buy? Video game?
Or
Thing with value. Cars like that Tesla, that ugly Tesla refrigerator on wheels. How about that? That's $100,000. Now I'm evaluating it. If I look at that thing, it's brand new, this I walk by it, I evaluate it for what it's worth. Do you understand what I'm saying? Evaluate, value, worth. Car's worth $100,000 now. But later on, I'll evaluate it again because it'll be a different year. In 2025, I'll look at it and I'll say, this car is worth $10,000 because it's junk and it's ugly. Okay, that's giving a value to it. If you tell me when I'm looking at it, if I'm evaluating it next year, I'm plugging in next year numbers into the equation that tells me what it's worth. Okay, that's what we're doing with evaluating. We're trying to figure out what the value is. So we're trying to figure out our sales of value by looking at plugging in a number. And so when I charge $20, I'm only going to sell 10 items. That's the value of my item that I'm selling. It's only good. I'm only going to sell 10 of them at $20. If I want to sell 500, I have to cut the price in half to 10. What if I charge $5? Am I going to sell more or less? What do you think?
you're gonna double.
A lot more. If I charge $51, oh, too much less. Okay. This function is a natural log function. We'll talk about it, but it does not. When I look at it like this, it looks kind of weird, but it does go through the data points. Let me try to make it go through the data. But you won't have as much problem as I'm having, but the data points, because that's what it looks like. Let me use the wrench. I'm not charging less than $0, so I don't need all this X. So I'm going to put a 0 there. And then I don't need to, I'm not charging much more than, what do I say, $50? That's what the natural log regression looks like. Okay, it looks like the exponential one, right? It should, because it's supposed to go through those data points. It should look very similar. It looks very similar, except what? Remember the exponential regression? You don't have to remember it. I can bring it up. Just bring that baby up. There's the exponential regression. There it is. Do you see the difference? They kind of look the same. But this exponential one has a horizontal asymptote at 0. You never sell less than 0 items. But the log one, definitely around $20, it starts to go below 0. Okay. Someone see that? It's down here. That's the natural log one. The other thing is the exponential one just keeps going. On the one side, just keeps going up, 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 up. This natural log regression, if I zoom out, you'll see that it has a vertical asymptote. So the natural log has a vertical asymptote, and we know where it is. It's right there. That horizontal, that natural log function does not go past that black line, but the exponential one, that does. For sure, the exponential one. So if I zoom out, you'll see that one of them. Let me get rid of the natural log one. There's the natural log one. Let me keep that vertical line in there. There's the vertical asymptote. I just want to there. This exponential will go past that black line. Okay. Change the wrench. You see how it's gone past the black line? See, the exponential does go past the black line, but the natural log one will not go past that black line. Because that black line is a vertical asymptote for the natural log for this. Now you can't see it, but it's there. It shoots up. It goes up like that. And it actually goes up really fast. All right, so let's break up in our groups and do it. So evaluate and solve. Okay? Let's do it. Where are our people? I have how many breakout rooms? 4? Is 4 enough in this class? 1, 2, 3, 4? Okay. Who was in 1? You were in 1? Who was else in 1 with you? Any of these people? Jake Brady. So you have to join because I think it's just you and Jake. Who's in room 2? Remember? 1 was there, group 2 was here. Aren't you in there, David?
I would think of my group's number one.
Your group is number 1? You're with her? Are you with her?
Yeah, I'm with them.
Okay. All right, so you can move over there. Who was sitting over here? You were group 2, right?
I think my group was.
Your group. Were you with him?
Yeah.
Oh.
Yeah.
Oh, so you guys were sitting here. It was 1. Who was sitting over there? Were you sitting over there?
Me.
Yes, it's
Oh,
Stephanie,
yeah.
right? You're in group 1 also?
Yeah.
Oh, lots of group 1. How about you guys? You're 3? Who is in 3? Who's in 3 with you? And anyone else?
The rest are all online or didn't show it.
I know, but are you gonna log on so you can join them? Right? Okay. Okay, so join the room that you're in. You guys at home need to know what room you're in, what group you're in. I had 4 groups. I can look them up. Yes. That looks good, but also was online for you to do your,
Oh, dude, so we need to put that in.
you can, yeah.
So I just change the light.
Just turn it on, just turn it on, click on the little circle. There you go. There you go.
Do I need to plot that point?
Be nice. There you go. Okay, I need to put some of these people in rooms, but I don't know where to put them. Do you guys know what room you're going in?
Yeah, room 2 or group 2.
Chris is going in room 2. Who else is in your room with you, Chris?
I think it was, I don't know if he's on the call right now, but Octavio was in my group. Well, it was Octavio.
Michael?
Michael, yeah.
Michael C or Michael? There was more than one Michael, but Taylor, was he in? Justin? Was Justin in your group?
I'm in group 4.
Taylor's in group 4. Okay, so group 4, Taylor goes in group 4. Momin, what group are you in?
I'm not sure the group number, but I was with Stephanie.
Stephanie, what group are you? She's not here. Justin. James, Jake. All right,
I'm in group 3 with AJ.
James in group 3.
Professor Porter, I have a question after class?
Okay,
Can you stay on Zoom for like 5 more minutes after?
sure thing, sure thing.
Thank you.
Okay, I'm still have people unattended.
in group 1.
You're in group, Justin, you're in what group?
Group 1.
Group 1?
Yeah, think so.
Who else is in group 2?
Justin has Chris and Michael in it.
Okay.
And, but what group are you guys right here? Are you group 1?
Yeah.
Are these people in your group? Your group
No,
had
I'm in group 2 then.
7 people in it? No, just
There is one more guy, I think, yeah.
Dennis said he's in group 3. His mic isn't working.
Chris, you're in group 3?
No, Dennis said he was in group 3. His mic isn't working.
Dennis is in group 3. Okay, Dennis and James are in group 3. I'm still, Jake. What group were you in? 2?
This.
Hold on, I'm just gonna look at the cubic encoder.
Oh, was he skip?
AJ in his group, he had Alexis, Jimmy, Akash, Dennis. Dennis is in group, is with AJ in group 4, right?
Group 3.
Group 3. Okay, Dennis is in group 3. All right, and James, that's James Seats. He's in group 3 also. All right, so you guys are in group 3. Will one of you join group 3?
Yeah.
AJ or Akash? Okay. That's one group down. Join the Zoom. Genesis. Genesis had Tatiana, David, and that's it. Joseph, you didn't post? Shame on you. Oh, where? Oh, there it is. Good. Okay, sorry for that. No shame. Okay, so the 4 of you, so you have nobody else in your group then?
No, it's
Who?
Jake.
Jake. So you need to join him. What group is that? Room 1? Okay, so one of you has to join room 1 so Jake can talk to you. Okay, next. Michael Charles. Michael Charles, what group number is Michael Charles in? He's with,
Okay, wait.
Michael Charles had Stephanie, Sebastian, Moment. Michael Charles has Moment in this group. Okay. Moment, you're in group 2 with Michael Charles and Chris.
Wait, and
Okay, but Chris didn't post in this week, so okay, so. All right, I still have somebody left. Group 4, Taylor's in room 4 waiting for David. You're in,
Yeah, I'm Zoom too.
but you can you just join the room that you're in, which is Zoom 1? Jake, I can put you
No,
in.
I'm not with Jake.
You're not with Jake. But who are you with then?
Just there is.
Which of these people is in group 1 with you? Here we go. Group 1. Oh, that's group 3. Genesis, Tatiana, Joseph, David. So who, you said Jake was in your group.
Yeah, it's Jake.
So you have to join group 1 because Jake is sitting in room 1 waiting
How
for
I
you.
do that? I don't know.
David, now you're in room 1.
Thank you.
Okay, so I still have Justin, no, Mike. No, Justin and Michael C are in where? Michael C bumped himself out, but Justin, what group are you in?
I'm pretty sure I'm in room 2. I'm in group 2.
Room 2 with Chris and Moment?
Yeah.
Okay, well, there you go. And Taylor's all by himself, so it's got to be Michael C. I remember Michael C being with somebody else. And I'm throwing you in there for now, so I don't want him to be alone. Okay. You guys know what you're doing? Is your producer producing?
it's
AJ, you guys producing?
Yeah, we're done. I just.
But did you join, who's on Zoom with the rest of your team? Oh,
What?
are you on Zoom? You just abandoned your teammates? They're just
Right, I just told you to log on to Zoom, dude.
log on to Zoom, you both got computers.
I'm feeling left out here.
Bro, stop talking.
I'm feeling left out. Go ahead. Okay, open all rooms. There we go. Smell like time to get these people in the room.
I tried telling you. Yeah, hurry it up, bro. He's waiting on.
I'm waiting for things to happen. Why is that stuff happening? Okay,
Just gonna log, just check.
okay, where's the what's on?
I still need to keep that.
Just tell me that was online. Yeah, and label that point there.
Which one?
Click on that point there.
So just this.
So the point that where they intersect, you don't have, those are all evaluated, you have no solves. You need to click on the, click where those two lines intersect. No,
Right here.
no. Okay, can you zoom in a little on that dot,
It's exponential.
right there?
So
That's
what-
74, 74. So put 74, 74 in your table. I don't care about the other one, 74.74. There you go, and then it's 215 pounds.
That's all I need about.
Okay, post it.
Or whatever. And. So. So. You put E equals me to no. But if you look at my comment, whatever. Okay. That's, wait, so that's.
Michael Charles was in group,
Wait, I'll just.
was with Moment and Stephanie. Michael Charles was with Moment and Stephanie. Hold on. No. Michael Charles was with Moment and Stephanie is in two.
Yeah, I'm just gonna get it going.
Yes, what's up? Yeah, you can leave it there.
Okay.
I don't care, but look, we need that point right there that near the red dot. You put it in 24. Keep zooming. Oh, yeah, that's it. You got it. That's it. Perfect.
Thank you.
Make sure that they know that's your solve. Okay. Taylor is in room 4 by himself.
Wait,
Michael. Why are you sitting here in the main room? Go join your other room. Okay. This is the-
And some people trust me.
Hello?
Hello?
Yeah, Professor, I don't know, I'm not sure, but I think I might be in the wrong group.
What group were you in?
I was with, one sec. I was with, one sec.
What's your major?
Major is business administration. Yeah, I was with, yeah, I was with Michael Charles and Sebastian Flores. Yeah, that's what it says for the cubic and quadratic.
Michael Charles is in group 2, but business one, if you want to join group 1 with David and Jake and Joseph, you guys could take another person, maybe. Just throw in another evaluate. Make sure somebody says something though.
Yeah, it's because like
Make them
for,
say.
for like for like the past ones, like I've just been commenting on the one with Stephanie on it because she was in my group originally, but I'm not sure.
Just on
if
here,
she's-
so join one and that way you can have something to join. Group 1 has David, Jake, and Joseph in it. David, so why don't you join room 1? Chris and Justin, I don't know what they're doing. If you're in the group with Chris and Justin, that's fine if you want to do that. If you want to work with them. I don't know what they're doing. About to go in there.
All
Check on
right.
it. So you wanna go in there or go in room 1? It's up to you. Let me go check on them and I'll know what's going on.
Okay, that's
Look, if you have more people, you can just let that, they can just pick a different value, just put more numbers on the table. You're only gonna have one solved, but you're gonna have a bunch of evaluates. And people can read them. People can say, according to the exponential regression, like they can read it out loud and record it on, and that counts. That's a thing. If they would do it, they don't do it. There's nothing for me to play.
Sorry, value we should do it then.
I don't see the function, I only see the line.
Nice, this is the sample, much
Oh.
more sweet, I think. So, the question for what I don't know is if we have to put.
That's a solve. That, because it's 26.6, they're solving, oh, maybe they aren't. What the hell is this? Population in Jersey, 10.9? No.
No?
No, because why would you use 10.9? It's 11. So the problem is zoom in more. That touchscreen now, sorry. I'm gonna touch your stuff. Can you move it up for that? Sorry, Michael. Greasy fingers on your screen. There, like you see the difference between the data point, which you have right there, which is one of them, and click on that.
Here?
Yes, that's 26.87. So put 87 in instead of 0.6, and then you'll have a nice. You'll have.
That's the solve with the value.
It's so. Don't take the whole thing. Just the 22060.
Okay.
Just that. Yeah. Copy. Paste it in your X0.
Okay, cool.
Okay, so now it's 11.
Yeah.
That's what we call a solve. Because you're solving for when you want 11, and it happens then in 2020. That's when the New Jersey population of New Jersey is going to be to 11 billion. So you only need one solve, and that's a solve. Just make sure it's posted. Make sure that's posted with your table, and then you have a bunch of people. Some people can evaluate, some people, one person's going to solve, one person's going to evaluate, and then people can, another person can evaluate, but somebody's got to say it, because, and when I say it, I mean record it. Because it works better if you record what you're saying. Once you have a writer, once you have a speaker, have somebody record that.
So the value should look like that or
So
that's the solve.
Oh, I'm sorry, down there. Yeah, that's evaluate.
Yeah. because
No, but that's not evaluate.
Oh,
I'm
it's not?
sorry, that's no. Other way around. She's writing it. You want to write it like that. E of X equals 11.
Is that the solve with the value?
I don't know. That's not.
was that not right?
Yeah, E of X equals 11. X equals
X equals
26.7. It might be right, but it's since both of the numbers are like so many decimal places, I don't know what you did. Did you evaluate or did you solve? The way you wrote it is as a solve. But he's gonna do a solve with 11 if it looks nice. Yours looks confusing. It's like,
Oh.
you know what I'm saying? If I was gonna solve for something, if you were gonna solve for my age, you wouldn't solve for 53 3/4 and 10 days. You would solve for like 53 or 54. You would want a nice number to be your output. His is 11. Yours is 9 point whatever. It's like something. No one's solving for that. Nobody cares about the points, whatever, although
Wait, that's not an evaluate?
yours is more like an evaluate. To do an evaluate, all you have to do is write E of 2021 equals that.
Oh,
Just put the 2021 in for the X.
Okay.
You're writing it as a solve.
How we write it as a value.
E of 2021, not E equals E parentheses 2021 equals that. Now it'd be better.
okay.
You're doing the solve.
Not do the value.
No, you're doing the solve. Put in X
Okay.
in for 2026, put in X in. Yep, put in X and then comma, no, at the end. Comma. No, at the end, there.
Yeah.
Comma, and then X equals, like, just delete it.
I'm sorry, that's not.
I don't know when the population will be 11, but it's gonna be 10.
Okay, now I
She's
guess.
saying
So I'm doing.
the population in 2021 is gonna be 9.2. That's an evaluate, that's so, thank you.
So mine was late.
Just make her do it right, and then have somebody say it in words according to the exponential regression, whatever the population will be. So you're doing an evaluate. So your person's going to say, according to the exponential regression, in 2021, the population will be 9 point something, and that's how you say and evaluate.
Okay.
When he says his, he'll say, according to the exponential regression, to get 11 million people, to find 11 million people in New Jersey, that's going to happen in 2026, something, whatever.
How do you delete it?
You
Oh,
won't delete it. Don't delete it, just edit it.
Oh,
If you
Oh, I see.
delete it, bad things happen.
Okay, so you're doing the following right now?
no. Oh, yeah, I fixed it.
And your children's children will be. Who are you?
I should have posted it. Would you next time? It is. Or would you rather-
You can write if you want. You can always say according to the exponential regression in 2023.
Hmm.
We have 11 million, it will be 2026.
Let me take attendance. Before I forget, and then we're gonna get back to our.
9, 7.
Does that, it makes sense to you now? Maybe, maybe not. I'm trying to, these are important concepts. Solving it all, you spend an entire course solving equations by doing the like, and now I'm trying to show you, you can use a computer to solve. And it's not just that the computer solves, you're working backwards. You're trying to find something, you're trying to predict something. You want to predict when COVID's going to reach 1 billion people. That would be solving. You have an outcome you're looking for, and you want to know what the input would be for it. Okay, height and weight, you guys back there. I want to know when I'm going to lose weight and be 180 pounds. I'm working backwards. I'm going to have to get taller, aren't I? No, 180 pounds, I have to get shorter. Start cutting off limbs, and then I'll be sure. Okay, Justin, was he here? Yes. Joseph's here. Michael Charles was here. Sebastian was not here. Emiliano was not here. Taylor was here. Octavio's not here. Tatiana's not here. Jake was here. Christopher was here. David's here. Janice is here. Akash is here. Dennis. Was Dennis here? I feel like he was, but I don't remember my absence.
So the evaluation is.
Alexis, I don't remember seeing Alexis. I don't remember seeing you. Momin was here. AJ was here. Jeff absent. Michael T absent. Aisha, this woman's got to be removed. Do you even know what Aisha looks like? That Aisha has done nothing. I don't remember what she looked like at all. I don't even think she posted a selfie.
The one that I got.
Yeah.
This great.
To the point that you posted with, it's the any, or it's the end.
Because I think it's supposed to evaluate for that.
Pictures don't even remember Eric. I don't. That's what Octavio looks like. Tatiana, that's a good picture of you.
Thank you.
That's Emiliano. I don't remember seeing Sebastian. There's Dennis. Okay, so that person didn't even, I'm just gonna see if I can remove them.
So. What is it?
Oh, she did the academic integrity agreement.
That's fair value. Fair value.
Row visibility. Okay, so. Take it off. I'll try to take her off. Thanks. I don't know why that was so hard. Okay. All right, finish up. We got 2 minutes.
You can do that for the solver.
I did.
Oh, you did?
But
For the log.
Yeah.
not the last night. Oh, you guys are working a lot right now?
Yeah.
Okay, so, sorry. If you're looking for the link to.
Forgot that was on live. All right, I'm closing the breakout rooms. You okay, Mike C? Michael C and Moment, where are they? Are you? All right, I have to end the breakout rooms.
So for the log, we have to. Oh.
Dennis was here and I marked him absent. So was Taylor. All right, finish up. 1 minute. All right. Get started again. Let's have a lot of stuff to cover. We talked about transformation of functions a little bit. Actually, let me start with the beginning. Let's start at the beginning. What is math? Math is what? The language. And pre-calculus is what? Someone from home? Justin? Momin? What is pre-calculus? The study of what? It's on the screen written 3 times. Functions. Thank you. So what are the ways we can represent functions? You get information from the real world, comes in a 4-letter word, begins with D. Data. Thank you, Alexis. So data. Then you can do what to that data? You can
graph it.
You can graph it. When it's just data, we usually call it a plot, but that's fine. Then you can take those points and you can create a something out of it. A regression is a type of function is that begins with an E and it has one of these signs in it. The sign that looks like an equal sign. Equation. So you have data, you have graphs, you have equations. Okay, and then you can graph those equations too. Okay. Once you have equations, you can move them. Transformations are ways of moving them left, right, up, down. With Desmos can help you do any transformations. If you don't understand them, you just graph it on Desmos and see. So I don't need to go over the transformation of functions, like the one, something stretches it. That's how the purple one in the number in front, that stretches. The green one raises or lowers it, and the red one moves it left or right. Okay, and there's specific order. The green one comes last. Because, please excuse my dear Aunt Sally. It's the reverse of that. So, or it's not the reverse, it's the same. Parentheses come first. Anything in parentheses come first. Then that exponent, see it's x minus 2, that minus 2 comes. So the function's going to move to the right by 2. And then multiplication comes next. So it'll be multiplied by half. That's going to shrink the function by half. And then the -3 will bring it down by 3. Okay. All right. When you go to Desmos, you can graph the function. But one of the things you can do is you can switch. That's not a great picture. This is a picture of domain and range. There's my person, right? Remember I was trying to look for a person? So there's a person in the domain, and the person down here is for the domain. Person up there is for the range. Okay, and this is a graph of a function, but it's a graph of a special function. I'll talk about it later. All right, so exponential functions. So let's talk about these things called inverse functions. When you create a function, you can move it around, and then that creates a new function, right? That's a transformed function. It's not the same, it's changed. Well, an inverse function is not the same, it's a different function. Okay, and what an inverse function is it undoes a function. Okay, so if your job is to add 1 to something, or if your job is to put a head on a doll, your inverse function plucks it off. Okay? That's what an inverse function does. So what it does mathematically is it switches the domains and the ranges. So the x values are switched with the y values. Okay? So let me go into Desmos for a second and show you what I mean by that. So here's some data point. Let me just plot a table. 1, 2, 3, 4, 5, 6. Okay, if I look at this, there's a plot of those data points right there in blue. Everyone see that? The blue dots? Okay, so what an inverse function does is it switches them. It takes the 4, 5, and the 6, and it undoes it. It says if I had a 4, it must have come from what number? Where did the 4 come from? What number input gave you 4? So now you're going to go back. 1. right? And then 5, you go back, you get 2, 6, you go back 3. Okay, those points are plotted in, let's plot them in red. Okay, so do you see they were 3 dots up here and now they're 3 dots down there? Okay. In fact, what happens is if you have any point, if you have any point, let me draw the line y equals x. It's y equals x becomes a mirror. See that line? That's a mirror to those 2 points. So these dots over here, anything over here moves over there and anything over there moves over here. That's what it looks like when you switch the x and the y. Because you're really taking the x-axis and the y-axis and you're switching them. Okay? So why am I telling you about inverse functions? So if I graph a function and I want the inverse, so y equals 3x. Okay, if I want the inverse, Desmos will graph the inverse by just switching the x and the y. I can say x equals 3y. And there's the inverse function. Okay, but it's not, that function is not written. You don't just switch x, y. If you want to write the function as an inverse function, you write f raised to the -1 of x. That's how you represent inverse functions. And then you switch the x, so you change that x into a y, or that y into an x. So you say 3x. Is that right? No. No, you have to solve it first. Sorry. I have to solve this for y. So how do I solve it for y? I could just divide everything by 3. Okay, copy. Paste. I can divide this by 3. And I can divide this by 3. And then end up with when I do that there, I just get y equals x over 3. So if I just type in x over 3, that's, oh, I can't say f inverse. Let me just say y equals y equals x over 3. See that? That's the inverse. So that's the inverse function is represented as f raised to the -1. So that's the inverse. That's how we write it. That -1 means inverse. Okay. So if this is the function up here, the inverse is that. All right, and you can get the inverse to anything drawn. Desmos will just graph what it tries to graph everything. Okay, so any function I put in there, I can get the inverse by just switching the x and the y's. All right. We don't write, if you, to the -1 power does not mean 1 over that. Okay, I'm telling my calculus students all the time. Any function raised to the -1 power means inverse function. It does not mean 1 over. Like you put 3 to the -1, that means 1 over 3. You put x to the -1, that means 1 over x. You put f of x to the -1, that means inverse. Doesn't mean 1 over. Okay? All right. It's a specific function, which is the x's and the y's. And if you want to know if a function has an inverse, it has to pass something called the horizontal line test. It's like the vertical line test, but if it has an inverse, you have to look to see if it passes the horizontal line test. So, for example, let me give a graph. These have inverses because they pass the horizontal line test. Here's one that doesn't. Y equals x squared. See that function right there? That does not have an inverse. You know why? So it doesn't pass the vertical, it doesn't pass the horizontal line test. Do you see if I draw a horizontal line, it hits the function twice. So there's no inverse. And that makes sense because we're trying to undo something. So let me do a table here. If I said, where did the number 4 come from? Where did the number 4 come from? In this graph, where did the number 4 come from? Oh, there's 2 answers. You see that? If I switch this table around, I'll have 4, -2, and 4, 2, and that won't be a function. But what I can do is I can restrict it. I can say x has to be greater than 0. If I do that, does that pass the horizontal line test? Yes. So that is an inverse. Okay, so why do I care about inverses? Let's take this. So this is Alex's question. Are these inverses to each other? Okay, well, one of the things that happens with inverses is if you put the one inside the other, this is called a composite function. If I put an inverse inside of the original function, composite just means like an assembly line. So that means if my job is to pluck the head off, and your job is to put the head on, and my job is to pluck it off. So if I do that in order, you start with the doll that has no head, I give it to you, you put the head on, you give it back to me, I pluck the head off. So we get back to what we started with. So if we put one function inside the other and we get back where we started, then they're considered inverses of each other. These two right here are probably inverses of each other. Let me show you how you can find out. You can take the okay, so I'm gonna take the function. I'll write them down. All right, f of x equals x minus 1 divided by 2. And the other one is g of x equals 2x plus 1. Now, the next thing they say is f of g of x. Okay? By the way, you can see the answer. Let me just up here. You can see that that's the line. It looks like it might be it. If it comes out to be the line x, then that's an inverse. So if it turns out to be equals x, then it's an inverse. If it's anything else, it's not. So let's see what it is. So I'm going to take this. Okay. Watch carefully. I'm going to copy the g of x function right here. Copy it, and I'm going to put it in for g of x like that. Now I'm asking, what's f of 2x? Now I'm going to take this f function right here, copy that, put it here. And I'm going to take this 2x plus 1. If I want to know what that is, well, what is f of 2x plus 1? Well, I put that in here. Okay? So that's all I did to find f of g of x. I took the g of x, and I plugged it inside f of x, and then I put it into the equation for f. Now, can you simplify this? Simplify this. What do you get? 1 minus 1 is 0, right? That's 0. And what's 2x over 2? That's just x. So this equals x. Okay? So f of g of x equals x. That's the one answer. What about the other one? What about g of f of x? So let me repeat the process, but I want g of f of x. Can anyone tell me what to do? Tell me what to do and I'll do it. I'm going to look this up. There's f, there's g. What do I do with g of f of x? What can I plug in first? And where do I put it? Okay. So what do you want to put in? Can't you see that f of x? What is that equal to?
X minus 1 divided by 2.
So I'm just going to copy that and I'm going to paste it in there. Okay. What does g of x do to anything? So I'll copy g of x down, copy it down. Get it there. So what does g of x do? It does that. So what is g of all of this stuff? If I put it in there, I have to put it in. Hold on. If I take this, I put it in for x in that equation, then I have to do that. And then I have to do that. Okay. Now, can we simplify this? What do I get? Tell me what this is. What do I do first? How about cancel out the 2's? Can I do that? And then what can I do? Actually subtract those. So this whole thing equals x. So I had f of g equals x and g of x equals x. So when I go back to Alex, I just put an x in here, and an x in here, and I say they are inverses of each other. Okay, when I do the other ones, these guys right here, I know what's going to happen. When I plug the one into the other, I'm going to get 9x. I'm going to put 3x in there, I'll get 9x. And I'll get 9x here. So are those inverses of each other? I said only if you get x. Anything else? No. not inverse of each other. Okay. There we go, correct. Okay, so that's what you do for this first problem. You plug one into the other and the other into the other, and if you get x and x, then they're inverses. If you get something that's, if you get 36x and 36x, not inverses. Okay. This is going to be x and x. Oh, that's not too interesting. Okay. Which one of these is inverse and which ones are inverses and which ones aren't? And B is. Are we good with that? Good. So determine inverse functions linear discrete. Okay. So for this one here, they're asking you to find the inverse functions, or they're asking you some questions. You see that G with the -1 in it? They're saying, what in the G function here, what gave the number 2? What was the input that gave the output of 2? Okay, so instead of, this is the function. If you want 2, 6, that's G of 6, G of 2 gives you 6. But what gives you an output of 2? Which one of these has an output of 2? -3. So that's the answer here. It's going to be -3 gave you that value. So, all right. This one right here is saying take this function and find the inverse. To find the inverse of a function, I'm going to go into Desmos again to find an inverse. To find the inverse, I'm just going to formalize what I just did there. I'm going to take x, what was the question? Shoot, I lost it. X plus 4 over 11. Okay, so I want x plus 4 over 11. So that's what I have, y equals that. So okay, if I want a picture of the inverse, all I have to do is switch the x and the y's. Let me get rid of all the other pictures here. Actually, let me just get rid of those. Okay, if I want a picture of the inverse, I just switch the x's and the y's. So the inverse is going to look like this. X equals that y. That's the inverse. And you see it looks like a reflection on the mirror, but it is actually fine. So what do? If I want to find the inverse, I have to solve this for y. So what can I do with that? First, I can multiply both sides by 11. 11's cancel out. So I have 11x equals y plus 4. I can take the 4 from, I can subtract 4 from both sides. And that's the inverse right there, 11x minus 4. Okay, so when I go back to my problem, I put in 11x minus 4. By the way, that will be the hardest question you have here. The last one is easy. Anytime you put a function and you put a little circle, that means composed. If you have a function and an inverse and you're undoing each other, they undo each other, and the answer is always just whatever number's in there, 7. Okay. So in any of these, H inverse of that, that's always just going to be the number that goes in there. Okay, and want to tell me what G inverse of 6 is? So which one is it? Is it 4 or is it 8? It's 4. Good. All right, that's enough. That's 2. Hold on, not done yet. Graphing a logarithmic function. When you graph the logarithmic function, you're going to do the same thing we just did with exponential. You're going to Desmos and you're going to graph it. Only there's going to be a vertical asymptote somewhere. In this case, it'll be at 0. But I want to show you something. To get log base 2 in Desmos, all you have to do is type in log and then do shift minus. And then it'll put a 2 there. You remember that? All right. graphing a log and finding its domain image. So for this one, you can find the domain image. It's the same. Once you graph it, you just have to look at the graph. Remember, there's a vertical asymptote. So a log function is going to be defined somewhere here, and everywhere else is range. So when the domain, there's no domain over there where you don't see a graph, that's where there's no, that's not in the domain. But the range is going to be everything. A log will have a range of everything. Okay. The domain of a logarithmic function, for that, you just have to take whatever's inside the log and say that has to be greater than 0. Logs cannot take negative numbers. So you know how one of the rules is you can't divide by 0 and you can't take the square root of a negative number. You cannot take the log of not just a negative number, it can't be 0 either. So I could take that 1 minus x squared, go into my Desmos, and I can say 1 minus x squared, and I have to say strictly greater than 0, no less than or no greater than or equal to. And so that means all of this region right here. So it's between -1 and 1, not including -1 and not including 1. Okay. All right. That's the whole quiz. So those are those 5 questions. But why did what was the whole connection between the inverse and the logarithmic functions is this. Remember this, y equals 3 to the x. That's an exponential function. It has a horizontal asymptote. When I graph the inverse, x equals 3 raised to the y. See that? That's a log function. That's another way of saying y equals log base 3 of x. Okay, so remember, in finding the inverse, you switch the x and the y, and then you solve for the y. We have no way of solving for this y. So we invented logs, so we could solve for the exponent. Y equals log base 3, because that's the base. So y is the exponent, and it's log base 3 of whatever is left over. So that's the function right there. We invented this because we have no inverse. We have inverses for x squared. We have inverses for rational functions, polynomials, whatever. Not polynomials. If you do it right, you do. But this we don't have an inverse for. So we had to invent them. So we invented logs. Okay? So we don't have time to tell you anymore, but that's why we invented logs. But we can do we just invented a new function. We have domains, we have ranges, we have horizontal asymptotes, vertical asymptotes. We don't have any bases. We do have zeros to worry about. There's a 0 right here. That's an x-intercept. Okay. There may or may not be a y-intercept. I told you, you can't plug 0 into this function. See, anything negative is undefined. Anything after 0, it would be fine. 0.001, that's fine. But anything 0 or before, it can't deal with. Okay. All right, so now that means next time we have to do properties of logs. So every time, you know how like we had faces and stuff in polynomials, and so logs have a lot of properties. It's a whole day of properties. And then after that, we're going to have equations with logs. So we have 2 more days of logs and exponents. People have the hardest time with logs and exponents, but if you use Desmos, you won't be embarrassed. Okay, and maybe you'll be able to solve these problems, and that would be great. Desmos is very helpful. Then we're going to start something called trig. Actually, I think we start it next week. So trig is that has boatloads of properties. In fact, they have so many properties, they call them identities, and there are boatloads of them. So I'm just letting you know. Okay, I'm done with this. Any other questions? You have a quiz. So post what you were working on today for both of them, because next week, and I want some talking. Somebody should say something. If somebody doesn't say something, then I'm just going to call on somebody for the group to say it. Okay. That's the end of that. Goodbye, Norman. Bye, Justin. Bye, Dave. Oh, David's here. Bye. Bye, AJ. Have good luck with your physical therapist.
Thank you. Have a good day.
Taylor and Dennis, are we good? I have to fix something. Hold on. How you did the test? How you? I never know which of these to press. List, I don't want the list, one by one, student activity, course report. I never get this to work. I really hate this particular program. It's so useless to me. Attendance, course report. Take care, have a good weekend. Where is the freaking report? Okay, what's your question? Guys. What?
What do I buy the access code?
You have a credit card?
Yeah.
Oh. So I need to put you back in. So they got took you out because I didn't know what was happening. Picture David, okay, you're Akash, so you're hidden probably.
Yeah, right there. Just see.
There you are, labeled and hidden. So now I just have to mark you. And they're not hidden anymore. And are you still disabled?
Oh,
You
yeah.
are, you are. Hold on, because I didn't do it right. Gosh, this, I have to do this. I have to enable, confirm, and then I have to unhide you. You should be able to get it even though I've hidden you. Okay, there you're back. Jake was here. Jake, are you still here?
He already left.
You're here?
Here? He already left. This is Chris.
Jake left?
Yeah, everybody, just me and James are here.
Why did he leave? Okay, well, whatever. Contact me. All right. Good, the coach is good. Chris, James, what can I help you with?
Yeah, I had the question. I have three things actually. It technically would be two things. One, is there a way for me to do the test one since the computer wasn't working in the first place? I couldn't access it because of the honor thing. Is there a way for me to take test one because I don't want it to affect my grade? And also, is there a way that I can make up quiz 2 and 4 because those are the only ones I missed because of work?
Is there who?
Is there a way for me to make up 2 and 4? Those are the only ones I missed. And is there a way for me to take test 1 because the honor system wasn't working?
I have to ask you a question. Have you had pre-calculus before?
Huh?
Have you had pre-calculus before?
Yeah.
When?
A year and a half ago.
Did you do well?
I did well, but the final exam messed me up.
So do you understand the material?
Yes, I understand for the functions, for exponentials, I do get the materials, yes.
Okay, because I'm saying this because according to Alex, I don't know if I'm still sharing screen or not, but 70% of this material from your knowledge check, which is really high.
Yeah, like I said, the finals from my last class messed me up. That's the only reason I kind of fell.
But listen, but here's what so I'll open, I can't do, can I do it here? I might be able to. I'll open it up for you and you can take it today. I mean, you have to take it on a computer that works though. And that's really the important, but you don't have to take it on whatever you're using.
Okay.
So you can take it on somebody else's computer and just try to get it to work somewhere. If you want to, you can use the school library or even libraries themselves, as long as they have a camera. Okay, you need a camera when you're being proctored for tests.
Okay.
Okay, and audio. Okay, but here, let me find out what James wants. James, are you there?
Yeah, I'm here.
Do you have a long question or short question?
Oh, it's kind of short. I just I didn't have time to like set up the honor lock thing because I've never even heard of it before. And
Okay.
last,
You
I
did-
like didn't see your text until I was done practice, which was at 6 o'clock.
Okay, so you didn't take the test either.
No, I still need to set up the honor lock thing.
Okay, so I will open it up for you both again. But it's painful for me to do this, so I have to stop sharing. Am I sharing screen with you?
No.
No.
Oh, okay, then I can do it without that because it's gonna show everyone's grades and everything. I need to go here. So when are you gonna take it?
I can do it tomorrow because tomorrow's my only free day.
Okay.
For Thursdays are my free days. Friday, Saturday, and Sundays I go to work like all
Okay,
day.
good. So I'll send it for you to tomorrow. James, can you take it tomorrow?
Yes, I was gonna ask that. Because I want to set up the honor lock tonight and take the quiz, and then I can do it tomorrow morning.
Okay, so I will set it up for tomorrow, but I have to tell you something. I'm giving an exam, a calculus exam, it starts tonight and runs all day tomorrow. So if you contact me, be very specific because I'll think you're a calculus student taking an exam. Okay, you're gonna run into, so you have to tell me you're in pre-calculus and you're having a problem, whatever. So you're gonna take it on the 10th. I'll give you till midnight.
All right, perfect. Also,
Actually, I'm giving it to 11:59 because I can't figure out how to do midnight on this thing.
all right,
Okay,
perfect.
okay,
What-
hold on. Yeah, it's not set up yet. I just set it, that was in honor lock. I just changed it to 11:59. And I have to save it, and then I have to check that you're there. Hold on. Oh, no, honor lock doesn't do that. Okay, now I have to go to Alex and check and make sure you're there. Assignments, test one. Exceptions. Add a new exception. Who am I doing? James
And Christopher. Chris.
Seeds, Jimmy Seeds.
Yeah,
and
Jim.
Christopher. How do you say your last name?
OG. Well, it's Auger, but that's French.
It's French?
Yeah, it's French. I'm French.
It's Auge?
It's Auger.
Auger. Oh, there's an accent then that's not there.
Yeah, like in America, they don't put that. So
Are you from France? I've been to France.
yeah, I'm from Marseille.
Marseille?
Yeah.
I have two very good friends from Vincennes.
Oh.
Which is outside of Paris. Okay, it looks like it's set up. Could you guys go in and see if it says that it's there? Do you have to go into honor lock? Oh, you'd have to go into honor lock. Go into Alex and see if it says just go into Alex and see if test one is available to you. It'll ask you for a password, which you can't do until you get an honor lock.
I'm driving right now.
Oh, well, then you'll have to let me know. I think I set it up. It's a pain in the butt. I have to set it up on both honor lock and on Alex. And if I screw up even the tiniest thing, oh, I forgot to do something. If I don't make it the exact same times, it won't work. So according to what I have written here for test one, you have until 11:59 on the 10th. And that's what I set it to honor lock, so it should work. Hopefully it does.
Thank you.
And for quiz 2 and 4, can I also get that for like 11:59?
What?
For quiz 2 and 4, I think yeah, it was quiz 2 and 4. Can I get a quick extension for those because I just missed them?
It's not that easy. Try not to miss them because this is what you do. I don't give it extensions on those things, but there are things called review quizzes or review questions. Can you see the screen if I share screen with you?
Let me see.
Am I good to go, Mr. Porter?
Not if you call me Mr. Porter.
Am I good to go, Professor Porter?
Yeah, I think so, yeah. Go ahead, you're fine. Good luck with the test.
Thank you. Have a good one.
Take care. See ya. All right, who am I talking to? This is O'Shea.
Yeah, yes, Olsey.
Okay, so Chris, go down to the bottom where it says review test 1, view 1 to Q4. That's where all the quiz questions are. So what I usually do is I make you do those. And then I count it as one of the 2 quizzes you missed. I can count this as it. Okay? Am I sharing screen? I don't think I'm sharing screen. That's why you can't see it.
Yeah, it's only showing the camera.
Okay, no, wait. What happened to it? Here it is. So
Okay.
way down at the bottom, you'll see something called review test 1, Q1 to Q4. Those are all the quiz questions. So that one has quiz 1, 2, 3, and 4 in it. So you did half of them, but you still didn't do the other half. So do this, and you have a grade. You'll get a grade for this. It's homework though. It's really easy to get help. You can ask for help from it, but whatever grade you get on this, I will use for one of your 2 missing grades. But it will be, it's not that, it's that you need to understand these questions for the test, for the midterm.
Yeah, the first 4 modules are pretty simple. It's just that I just missed them. I didn't have time for the.
Yeah, so don't miss any more quizzes because I don't really give extensions. It's too, I want to say that I'm too old and feeble to do this, but I'm not too old or feeble, but I do make mistakes and I hate myself when I do it, and then it makes me feel old and feeble. So
It's my fault. It's more my fault than anything.
yes, but so don't ask me to do extensions. I'll do it for the test because I said this in class. I have to have you take test 1 is an important test to take, but the quiz, they're not that important. They're worth very little to your grade. There's 13 quizzes. I generally drop 1 or 2. Sometimes I drop 3 of them anyway. So there's just no point in worrying about them at all. And they're only worth like 1% of your grade in the end anyway. So it's, but the test is worth more for other reasons because it helps prepare you for the midterm.
All right.
So, and it just helps you get honor lock to work. That's all. It's just about honor lock and for me to get a score on you. So like, according to this, you are, let me see if I can get you from here, Chris. No, never. To this, you know 69% of the material already.
Yeah, it was.
Yeah.
Yeah, it's only the finals that's really like the tests that really mess me up. I'm a very stressful test taker.
Okay, so here's what. Oh, so I did want to talk to you more about this. So yeah, so you actually, when you take this test, it's going to give you another knowledge check, and if you know how to do, if you can get a 69 again, you don't even have to get a 69, but you get 100 if you get whatever, some fraction of this. So what I'm saying is, I'm not worried about that. I'm worried about the problem that I have is that you had this material before, and it's so different when I teach the way I teach this material from the way you learned it in France. You didn't learn it in France, but
no, I learned it in New York.
Yeah, no, but when I taught this stuff, when I started teaching, I taught it at Rutgers. I've been teaching pre-calculus for lots of years. And the way my colleagues teach it is the same way that I taught it in 1980 something, 1990 something. It's when I started teaching pre-calculus, when did I start teaching pre-calculus? 1987. I mean, that's how long I've been teaching pre-calculus, but I'm just telling you, it hasn't changed for my colleagues and for most people, it hasn't changed. I do things really different. Alex is pretty traditional. It's just a computerized version of what I did in the 1980s. But the discussion stuff that we do, that's very different from, so you have to come to class and you have to sort of do those. You have to do those discussions because they're worth points. And then in the end, you're gonna have to do one yourself. And so the problem with doing well in this course for you is it's going to be easy to do the stuff on Alex, but then some of the other stuff is going to be harder. So you really can't rest on your laurels, if you know what I mean. You can't just be like, oh yeah, I know pre-calculus, I'm going to do great. I'm just going to stress out on the final. No, you might not do well at all because you'll stress out on the final, but you'll also lose points on the discussions and the project if you don't like keep on top of them.
Yeah, I'm trying to lock in. I'm trying to like focus on those two because I saw myself being dragged back to like how I like my old habits of like how I procrastinated and like stressed out over like menial stuff.
Yeah, so while you have the highest class performance, I'm looking here at the thing. As far as hours spent on Alex, you are the bottom 4. Okay, so everybody but 3 other people spent more time on Alex than you did so far. But that's just the Alex part. But since you know so much, I'm not so worried about the Alex part. But I am worried about discussions.
Yes,
So,
I'm going to try and get better in the discussion.
not to mention, so I figured out how to put discussion questions into Alex. So by the midterm, I will have discussion questions in Alex, and that will be fun.
Okay.
So you're gonna need to know how to do some of these things on these worksheets. So some people are not pulling their weight on the discussion stuff, but it's gonna catch up to them because I have those questions. I'm gonna basically be able to evaluate and solve starting from data. So, but I'll go over that for the midterm, but don't miss class because, well, at least listen to it on the live stream. By the way, is it still live streaming? It is still live streaming. Okay. So.
Oh yeah, I also watched your